4.4, definition of trig functions of any angle. Let theta be an angle in standard position with x, y, a point on the terminal side of theta, and r equals the square root of x squared plus y squared. So all that means is it's on the unit circle. Okay, so remember we talked about this being the unit circle because it was centered at 0, 0. Your r as your radius would be 1. So if we have sine theta, what was sine when we talked about our unit circle? Yes, sir. It was y. If we change our unit circle to a different circle with a greater radius or a smaller radius, then we would have to divide it by the radius. So we can take it off of that unit circle and put it on a different circle in general. So we would just divide by the radius. Why is the unit circle not have this on there? Because we would be dividing by 1. Does everybody understand that? So on our other one, we did not have it because we were specifically on the unit circle and our radius of the unit circle is 1. So y divided by 1 would be 1. So what would that make cosine theta? What? Y divided by 1 is y. Because anything divided by 1 is itself.
Okay, you said what? I was like, hold on.
Tan theta. Did tan deal with the radius at all? What was tan? Y over x. But remember that x cannot equal 0. Why? We can't divide by 0. Good. What goes with sine? What's your reciprocal function? So cosecant theta is, and what would I do to that? R over y. And what can y not be? Very good. What goes with cosine? What would that ratio be? But perfect. And then what goes with tan? Cotan would be but. So then over here, they give you kind of a visual of it. We have our X and our Y, our coordinate plane. I'm going to darken the X axis a little bit. And the reason I'm going to do that is my, my initial side of my angle. Remember, that's where we start. And then here's the terminal side of my angle. Because it's where we end. That is going to be our theta. This point can be anywhere on this terminal side. But that will be your X and your Y that all of this is referring to. That will be on the outside of the circle. Yes. And this from the center or from 0, 0 to that coordinate on the outside is going to be your radius. Because r is going to equal the square root of x squared plus y squared. Cannot be 0. We can't have a radius of 0. There would be no circle. It follows that the sine and cosine functions are defined for any real value of theta. However, when x equals 0, the tan, secant of theta. So look at tan and look at secant. Why is it referring to this one for x equals 0? Because they're both undefined, right? They can't be 0. Are undefined. For example, the tangent of 90 degrees is undefined. Why would the tangent of 90 degrees be undefined? Where is 90 degrees? Where would it be on this graph? Anywhere on the y-axis, right? It could be anything on the y-axis. If we're talking about the unit circle, you are correct in the fact that it would be 0, 1, right? But it could be anything now. So we're changing that radius. It could be 2, it could be 8, it could be whatever. But if it's on the y-axis at 90 degrees, what is your x-coordinate going to be? 0. So it doesn't matter. That's why it's undefined, because it's always going to be on there. And so similarly, when y equals 0, which ones are undefined? Cosecant and cotan. Of theta are undefined. So all that paragraph is doing is explaining to you which ones are going to be undefined. And you already knew that because we can't divide by 0. Evaluating trig functions, let -3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. This is super simple. You're going to look at those values. You're going to find what r is, and you're also going to find x and y. We already have x and y. If you can't remember this formula right here, y'all, it's Pythagorean theorem. X and y are your two sides. So a squared plus b squared is going to be r squared.
Please pardon this interruption. At this time, I need all current sophomores, last names beginning with P and going through Z. P through Z, current sophomores, and anyone else that is a sophomore who may have missed the registration meeting this morning. Please report to the commissary at this time. Thank you.
Hi guys, sorry. I know you're gonna miss me. Love you, Portland.
9 plus 16 is 25. How do I solve for r? Square root of 25 is 5. So now we have x is -3, y is 4, and r is 5. What is our ratio for sine? It's at the top up there. What is the actual ratio, the letters? Y over r. What's our y coordinate? What's our r? That's it. Cosine theta is x over r. Our x is -3. Our r is 5. And then tan theta is y over x. Our y is 4. Our x is -3. That's all you do. Same thing on the next one. So what do I have to do first? So if I use the formula that they gave me, it's the square root of -2 squared plus 3 squared. I don't care which one you use. I'm showing you both of them. I like to just go ahead and do Pythagorean theorem. It's a little bit easier for me to look at. 2 squared is 4. 3 squared is 9. 9 plus 4 is 13. That will not reduce. The thing about the 13 is under that square root. It cannot be in the denominator. You may have to fix these. Okay. So we're going to start with sine theta. We're going to do y over r. What was your y coordinate in your problem? So 3 over the square root of 13, but I can't have the square root of 13 on the bottom. So what do? So on the top, I get Perfect. That's it. Cosine theta is x over r. What's your x? -2 over the square root of 13. Fix it. And I get. And if there's any way that you can reduce that, you want to do that, but there is not in this case. And then the last one is the easy one. Tangent is y over x. What do you get? And it doesn't matter where that negative is. On the 3, on the 2, or out front, it's all the same. Okay, so don't stress out. All right. So the signs of trig functions in the 4 quadrants can be determined from the definitions of the functions. For instance, because cosine theta equals x over r, it follows that cosine theta, bless you, is positive whenever x is greater than 0, which is in quadrants 1 and 4. Remember, r is always positive. That will never change. Now, leave it right here for a minute. Don't go anywhere. I just want to remind you, in our quadrants, because it's going to start asking you, in what quadrant is cosine positive? Know your 4 quadrants. And then some of you did not do very well with this on your quiz, labeling which ones are what. So this is positive, positive. This one I would go left and up. So that would be negative, positive. This one is left and down, so negative, negative. And then right and down, so positive, negative. All right, so again, those you should already know. The new part, I want to remind you that sine theta is y over r. Cosine theta is x over r. And tan theta is y over x. And then I'm going to make one more thing for you that'll help you out. You need to know these. Okay, you can derive them and that is fine, but you don't want to, which means you can come up with the answers yourself, but it's easier if you just go ahead and memorize it. So make your coordinate plane again. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. In each one, write sine, cosine, and tangent. So a column of sine, cosine, tangent in each one. So this is like a little cheat sheet for you. I'm gonna do one more thing. You don't have to do this if you don't want to, but I'm gonna explain to you how we get everything that we get. Here, negative, negative. All right. What's your ratio for sine? Y over R. R is always positive. What kind of Y coordinate will you have? Positive. Positive over positive makes a Positive. So think about it this way. Your y coordinate has to be positive in quadrant 1. Your ratio or your radius is always positive. What about cosine? It's x over r. So our x coordinate is positive over r is positive, makes positive. And then tangent, x and y are both positive. All right. And the next one, quadrant 2. Sine is y over r. What is y? Y is positive. R is always positive. So positive over positive makes positive. So your sign in quadrant 2 should be positive. What happens here?
Negative x.
Negative x over positive r makes a negative. Positive y over negative x makes a negative. So everybody see what I'm doing? I'm going to go ahead and tell you the rest of them instead of going through it. Negative, negative, positive. And then this one is negative, positive, negative. And again, it's just based off the ratio and the signs in there. All right, so given that tan equals negative 5 over 4, tan equals negative 5 over 4, and cosine is greater than 0. What does greater than 0 mean? What kind of numbers are greater than 0? Positive numbers. Okay. So let's stop there for just a minute. Why do they tell us this? What kind of value is tan theta? Negative. So what quadrants is tangent negative?
4.
4 and 2, right? But then it says that cosine is, which is positive. So which quadrant are we looking at? We're looking at quadrant 4. All right, so we're like normal. So we're in quadrant 4. It wants us to find sine and secant. All right, sine and secant. So remember that tan is y over x. I'm going to put this negative out front and make it negative, and then your 5 over 4. To find sine, what do I need? Y and R. What do I not have? R. How do I find R? And what's going in that Pythagorean theorem? So 5 squared plus 4 squared equals R squared. Or if you remember the other formula, that's fine. What is 5 squared plus 4 squared? What's 5 squared? 4 squared. 25 plus 16. 41. And then square root. You don't have to change it. Leave it as the square root of 41. It wants to know sine of theta. Sine is what ratio? But we were in what quadrant? So sine should be what? Negative. So that's the reason that you have to figure out what your quadrant is. Okay, to figure out which one the negative goes with. Does it go with the 5 or does it go with the 4? It doesn't matter if you know all this. Your y was what? 5. Your r was? And it said it was negative in quadrant 4. I can't have that. What do I got to do? So that gives you negative 5 square root 41 over 41. So again, all this tells you is that sine has to be negative. So we're looking at quadrant 4. What about secant? Secant is the opposite of what? I thought you said it. Cosine, which is? Cosine is supposed to be x over r. So what is secant?
R over x.
R over x. What's your r? Say it again. What's your X? Is it negative or positive? Why is it positive? Is everybody okay with that? Does everybody see that? So if the cosine is positive, secant has to be positive because it's just a reciprocal of itself, right? Positive over positive, still positive over positive. So that's it. Any questions? So the biggest thing is figuring out what quadrant we're going to be in. So let's look at the next one, and I'm going to leave it like this so that we can see that top part. Sine is 4/5. What does that tell us? Sine is positive. Where is it positive at? 1 or 2, right? So above the x-axis. But tangent is, what's less than 0 mean? So what quadrant are we in? So we're looking at quadrant 2. You guys have that on your paper, right? This little thing. All right, I'm gonna move it on up. So remember that sine is y over r. What do we not have? X. So remember we do x squared plus y squared equals r squared. We don't know x. We know y is 4. We know r is 5. Always put positives in here because they're going to multiply out anyway. So when you square it, it's going to be positive. So I don't ever use the signs in here. We get x squared plus 16 equals 25. How do I solve? 25 minus 16 is 9. And then square root of 9 is 3. It says find cosine theta. From this little chart up here in quadrant 2, cosine should be negative. So cosine is x over r. In this case, ours is going to be negative. What's our x? What's our r? That's it. That's all you do. But you have to know that chart. Yeah. Why didn't you know before class? Day 1, I told y'all I don't like you going under my notes. I do not like it. Next one. Evaluate the cosine and tangent functions at the 4 quadrant angles 0, pi over 2, pi, and 3 pi over 2. Where are these at? Where's pi over 2? Where's pi over 2? Yeah. Anytime they talk about 0, pi over 2, pi, all of those are always going to reference unit circle. They would give you the coordinate if it's a weird circle. So where's pi over 2? Yeah, I got you. At 90 degrees, you are exactly right, which is 0, 1. Where is pi? At 180, what's that coordinate? -1, 0. And what about 3 pi over 2? 270, and that coordinate is 0, -1. All right. Evaluate the cosine and tangent functions at the 4 quadrant angles. What's at 0 degrees? 1, 0, right? We need to know our x and y so that we can get our r. What do you know our r is going to be? If we're on the unit circle, it's always positive 1 because we're going 1 down, 1 left, 1 up, 1 right. Is everybody good? So on this one, your x and y is based on whatever degrees you are, and your r is going to be 1 the whole time because it's on the unit circle. How do you know it's on the unit circle? It gives you those values that are on the unit circle. So we're going to start with 0 degrees. Cosine of 0 degrees. Remember, cosine is x over r. At 0 degrees, what's our x coordinate? 1. What's our r? 1 over 1 is 1. We need to do tan of 0. That's y over x. What's your y coordinate?
One. That is
0. What's your x coordinate? Which gives you 0. That's your first one. Now we need to do pi over 2. So we're going to do cosine pi over 2 and tan pi over 2. They're the same ratios. The only difference is it's a new point. So pi over 2 gives you 0, 1. So what's your x over r? What's your x coordinate for pi over 2? 0. What's your r? Which gives you 0. Tan is y over x. What's your y coordinate? For 90 degrees? 1. What's your x coordinate? What's wrong with that? It's undefined, and you can just put it like that. We're going to do cosine of pi and tan of pi. Cosine is x over r. Here's your tan. I mean, sorry, not your tan. Here's your pi, -1, 0. What's your x coordinate? -1. What's your radius? 1. So your value is -1. Tangent is y over x. So at 180, what's your y? Your x, which makes 0. And then the last thing I gotta do is cosine 3 pi over 2 and tan 3 pi over 2. Cosine is x over r. What's your x coordinate? 0. What's your r? Which gives you 0. Tangent is y over x. So you're looking at your 270. What's your y? Your x, which means that's it. Any questions? All right, evaluate the sine and cotangent functions. Sine and cotangent. So what was sine? What's your ratio? Y over r. What would cotan be? Very good. X over y. The quadrant angle is 3 pi over 2. So what is the coordinate? We just did it. 0, -1. So this is your x. This is your y. What's your r? 1, because it's on the unit circle. Okay. So we're going to do sine of 3 pi over 2. What's your y coordinate? -1 over 1 is -1. Then we got to do our cotan 3 pi over 2. It does x over y. What's your x? Your y is, which gives you 0. Not hard. You just got to know the coordinates. All right. Reference angles. The values of the trig functions of angles greater than 90 degrees or less than 0 degrees can be determined from their values at corresponding acute angles called reference angles. All right. So here's what a reference angle is. Let theta be an angle in standard position. Its reference angle is the acute angle. And this is called theta prime. It's like an apostrophe. Theta prime. Formed by the terminal side. What's terminal? The end side of theta. and the horizontal axis. Which one is the horizontal axis? The x-axis. Reference angles for theta in quadrants 2, 3, and 4 are shown below, so I'll explain them to you. I'm gonna make a 90-degree right here. This is your X, this is your Y axis. We're gonna look at quadrant 2. So everything in quadrant 1 is pretty simple. Quadrant 2. If I have an angle over here, this angle is your theta. This angle is your reference angle. So again, if you want me to make it a little bit darker, the angle that we're looking at is this one. Again, going clockwise, counterclockwise is your theta. And then however far it is from the horizontal axis is your reference angle. So to get theta prime, you're going to do pi minus theta if it's in radians, or 180 minus theta if it's in degrees. They're both the same thing. We're going to work on quadrant 3 for this one. So I have an initial side where it's supposed to be, a terminal side in quadrant 3. We typically go counterclockwise for our theta. Our reference angle is going to be from 180 to the terminal side. So to find that, to find this little reference angle, you're going to do theta minus pi if it's in radians, or theta minus 180 if it's in degrees. Now, do not stress out because I'm going to teach you how to do this. So just write it down to begin with. And then we're going to talk about quadrant 4. So you have an angle over here that looks like this. Again, we would go counterclockwise, which is a huge angle. This is going to be your reference angle. And the way that you find it is you subtract it from 2 pi, or you subtract it from 360, depending on if it's radians or degrees. All right, so again, when you're looking at these, it's kind of looking like it's super complicated, but it's really not. So I'm going to give you like visuals of all of these when we do the examples. So I want you to find the next 6 examples are finding reference angles. And of course, we're going to use that, but I think you can see it better than you can read all of this. Okay. So the first one that we're going to do is going to be 300. Where would we find 300? What quadrant? We would find 300 in quadrant 4. I'm gonna draw this out for you real quick. Remember that this is 0 or 360 or 0 pi, 2 pi if it's radians. What was this one? Well, let's go to the top. What's this one? Degree wise.
90.
Radians.
5, 2.
All right. So what is pi? Literally, what is pi?
3.14.
So what would 2 pi be?
6.8.
6.28. What would half pi be? Do it in your calculator. 3.14 divided by 2. 1 point, oh, you can't even see that. Sorry. 1.57. This is important in just a minute, but I just want you to know where it comes from. What's this one going to be degree wise? And then it's pi or 3.14. On the bottom, what is this degree? What's your pi? Remember 0 pi, 1 pi over 2, 2 pi over 2, 3 pi over 2 is 4.71. 3 pi over 2, which is 4.71. All right, I'll tell you why it's important in a minute. 300 is between 270 and 360, which would be quadrant 4. Okay, it says in quadrant 4, we just go backwards. So 360 minus 300. Basically, how far is it from the closest axis? 60 degrees. So that's your reference angle. All right, so then you guys see that this says 2.3, right? Where is the 2.3 coming from? It is radians. Here's 6.28 radians, 1.57 radians, 3.14, and then 4.17. So where would 2.3 fall? So quadrant 2 says that your reference angle, quadrant 2, that's this one, is pi minus theta. In this case, since we made it 2.3, you can do 3.14 minus 2.3. And you get 0.8416 when you put that in your calculator. Now, I did just pi minus 2.3. If you do 3.14 minus 2.3, you get a smaller decimal, 0.84. Does everybody see what I'm saying? Everything's a girl for that one. I don't even know what that is. I don't know who put it on there. It didn't even have a last name. So, okay, perfect. All right. What about this next one? What's different about it? It's going clockwise how much? 135. Where would it fall if I go clockwise 135? Quadrant 3. Very good. So this would be 90 to 180. So it's going to fall somewhere in here. That's why we use quadrant 3. Sorry, that looks so bad. All right. So quadrant 3 says if we have the degrees, we do theta minus 180. So we're going to do negative 135 minus 180, which gives us negative 315, but I don't use that. I use the positive. So how would I find the positive angle at negative 315? What do you think? At 360. So 360 minus 315 is 45. So again, you want the positive angle. Okay. So now we have everything. So do the next ones. 213 degrees. Where's that going to be? Quadrant 3. So 213 is in quadrant 3. Quadrant 3 says How do you find your reference angle? Quadrant 3 says theta minus 180. Sorry about that. What's your theta? Minus 180, 33. That's your reference angle. All right. 14 pi over 9. How would I figure out what that one is? So let's see what the decimal is. 14 pi over 9 is 4.88. Where would it be? Look up here. Quadrant 4. Quadrant 4 says your reference angle is 2 pi minus your angle. Remember, in your calculator, you would just do 2 minus 14 over 9, put it in a decimal, a fraction form. 4 pi over 9. That's it. And then the last one, 4 pi over 5 gives you 2.5. Where would that fall? Quadrant 2. Quadrant 2 says pi minus theta. So pi minus 4 pi over 5. This would be 5 pi over 5 minus 4 pi over 5. Gives you 1 pi over 5. Everybody okay? Trig functions of real numbers. To see how a reference angle is used to evaluate a trig function, consider the point x, y on the terminal side of theta. As shown below. So again, we have our x and our y. I'm going to darken it a little bit. Doesn't really matter where you put the terminal side, it's all going to be the same. So there's your angle. Theta. This point on the end is xy. R will be your hypotenuse. We can make a right triangle. So this, you're not going to be able to see it, sorry, is going to be your reference angle in here. So remember we talked about that being your reference angle. This one would be your opposite. And this one would be your adjacent. Your opposite is a vertical. It's always going to be the absolute value of y, so it would come out positive. And your adjacent is a horizontal movement on the x-axis. So it's going to be absolute value of x. Okay. So I'll give you a second to draw that, and then we'll go through it. Don't stress out. It's not bad, I promise. This is the same picture that you've had. The only difference is they're adding absolute values on it. That's all. All right. So you know that sine theta is y over r, and cosine theta, not cosine, tan theta is y over x. For the right triangle with acute angle, theta prime, and side lengths of absolute value of x and absolute value of y. You would have sine theta prime is going to be your opposite over your hypotenuse. Or the same thing that we've been doing. You're going to have y over r, but this time we're just putting absolute values on the y. That's it. For tangent, tangent is opposite over adjacent, which is y over x. But again, we're just putting absolute values on them. That's it. So again, just put absolute values on them. So it follows that sine theta and sine theta prime are equal, except possibly in sine. I know that sounds crazy. What that means is one might be positive, one might be negative, but they have the same value. They would have like 3/4 and 4/5, but they might be different signs. The same is true for tan theta and tan theta prime, and for the other 4 trig functions. In all cases, the quadrant in which theta lies determines the sign of the function value. Mhm.
I need, we need one for your book because it's not on any of the. I was just
It's okay. I can get it to, I can, do you want me to email Ms. Wood?
yeah, that's.
Okay. All right. Evaluating trig functions of any angle to find the value of a trig function at any angle theta. Determine the function value of the associated reference angle theta prime. And depending on the quadrant in which theta lies, affix the appropriate sign to the function value. So again, that little chart that we made where it said in the first quadrant, sine, cosine, and tangent are positive. So if it lies in the first quadrant, then all of your sine, cosine, and tangent would be positive. So we're talking about making a little cheat sheet chart right here. There's no way you're going to memorize this, but you can know it based on the unit circle. You've memorized the unit circle. Hopefully some of you are going to do a little bit better on the next time we take the quiz. Huh? I don't know. It will not be tomorrow, but I want to try to give you your stuff back today. All right. Just for sine, and we're going to continue this on the next page, but we're just working with sine right now. If you had 0 degrees, remember your coordinate. What is your coordinate going to be there?
0,
0, 1, right?
right?
So what would your, at 0 degrees?
It would be 1, 0.
1, 0. So what would your sine be? No, like SINE sine, not SIGN sine. Your trig function, sine. No, we just did it, y over r.
No.
What's your y? At 0 degrees. 0 over 1, which will be 0. Now, what they're going to show you is going to look like this. Square root of 0 over 2. And we'll talk about y in just a minute. 30 degrees. You're going to have square root of 1 over 2. Then we have 45. I'm going to talk about it in a minute. We have square root of 2 over 2. At 60, We have square root of 3 over 2. So what do you think is going to happen at 90? All right. So back at our unit circle that we did the other day, at 0 degrees, our sine value is going to be 0, or our y is going to be 0. At 30 degrees, what was your y coordinate? 1/2. At 45 degrees, what was your y coordinate? At 60 degrees, what was your y coordinate? And then at 90 degrees, what is your y coordinate? Square root of 4 is 2 over 2 or 1. See how it matches the unit circle? So these things, you don't have to memorize this, because if you know the unit circle, you already know it. Does everybody understand that? Okay, so if you know the unit circle, you already know it. So we're going to fill in this chart. We're going to fill in this chart for all of these values for sine, cosine, and tangent. Can you memorize it? Sure. Why would you do that? Memorize the unit circle and you know the ratios. So unit circle and ratios will get you the same thing. All right. So this is going to be the degree of theta. Yeah, no, 240, isn't it? Was 235. Yeah, you can do. But if you get caught, I didn't tell you could. What I just say. Degrees, radians, sine, cosine, and tangent. We're going to do all of those same degrees that we just did. 0, 30, 45, 60, 90, and then we're going to do the other main ones, which are 180 and 270. The next row of this chart is going to be those degrees in radians. So what is your radians for 0 degrees? 0. What's your radian for 30 degrees? Pi over, we split it into 6 parts. 45, we split it into 4 parts. 60 is the second part of the 6. 90 is the second part of the 45. Pi over 2. 180 is pi, and 270, 3 pi over 2. All right, so then it's just showing you your ratios. So sine of 0, we talked about that. That's your y coordinate is going to be 0. The y coordinate at 30 degrees was 1/2. The y coordinate at 45. The y coordinate at 60. Square root of 3 over 2. The y coordinate at 90 degrees. Remember 90 is 0, 1. At 180 is 0. And at 270, -1. So we're just looking at the y coordinates all the way around the unit circle. Cosine is going to be all the x coordinates. So 1, 0. At 30 degrees, square root of 3 over 2. At 45, square root of 2 over 2. At 60, 1/2. At 90, your x coordinate is 0. At 180, your x coordinate is -1. At 270, your x coordinate is 0. So notice where we get this from. Again, you don't have to memorize this chart. You should know it from unit circle. Then tan of 0. Remember, it's y over x, so 0 over 1. And then we're just going to go through these. We've done these already where we get the square root of 3 over 3. 1, square root of 3. At 90, it's undefined. Why is it undefined? We divide by 0. The next one at 180 is 0. And then at 270 It's also undefined because we can't divide by 0. All right. Using reference angles, evaluate each trig function. I'm going to put this chart back up here. Sine, cosine, tangent. All the values of sine, cosine, and tangent are positive. Sine is positive, cosine is negative, tangent is negative. Negative, negative, positive. Negative, positive, negative. Just to remind you what that was. All right, evaluate each trig function. So cosine of 4 pi over 3. Where is 4 pi over 3? You guys remember seeing that? So if we go back, I don't want to do it. Let me do this one. So you guys can see it. We did 4 pi, not E, which is 4.188. We already did that. Where would it fall? It'd fall in quadrant 3. It's got to be bigger than 4.7 to go in 4. Okay, so quadrant 3. We have to use a reference angle. It says in quadrant 3, you take 4 pi over 3 and you subtract pi. Okay, so let me write those down. If it's in quadrant 2, you do pi minus theta, or 180 minus theta. If it's in quadrant 3, you do theta minus pi or theta minus 180. And if it's in quadrant 4, you're doing 2 pi minus theta or 360 minus theta. Those are formulas that we learned. If you just came back, they're in your notes. All right. What's 4 pi over 3 minus pi? Number 1 would be 3 over 3. 4 over 3 minus 3 over 3 is 1 over 3. Go to your chart. Yep. Right here. What is your cosine of pi over 3? So cosine of pi over 3 equals 1/2. However, what quadrant is it in? The third quadrant, cosine is negative. Okay, so let me go back over that all together. Okay, first of all, I have no idea what either one of you said. Second, I said I'm going right back over it. Okay, pay attention. 4 pi over 3. Remember we made our little thing a minute ago. This was 0 pi. What's pi over 2? $1.57. This is 3.14 because it's pi. 3 pi over 2 is 4.71. So there's your radians, 4.71. We said that 4 pi over 3 is 4.188. So where does it fall? Quadrant 1, 2, 3, or 4? It has to be in quadrant 3. Is everybody okay with that? All right. Quadrant 3 says you need to make a reference angle. You don't have to do that for quadrant 1, but you have to do it for everything else. To do that in quadrant 3, we do theta minus pi. What if it were in degrees? Theta minus 180. Is everybody good? So when I did that, 4/3 minus 1 is 1/3. Everybody okay there? So pi over 3. We're doing cosine of our reference angle, which is pi over 3. My chart said cosine pi over 3 is 1/2. But then I learned that this was in quadrant 3. Cosine has to be negative. Is everybody good? Yes, no, maybe. Maybe you are. Okay. All right. Let's do another one. Let's do C. Cosecant 11 pi over 4. Cosecant 11 pi over 4. What do we need to do first? Okay. So we're gonna do 11 pi over 4. What do I get?
Quadrant, 4.
Why is this one weird?
Because it's cosecant.
Yeah.
Oh, it's more than 1 because this would be 6.28, right? Oh, so what do I do?
Add another pi.
Not add it,
Subtract.
subtract it. So we're gonna take this 11 pi over 4 because it's too big and subtract 2 pi. When you put that in your calculator, you get 3 pi over 4. 3 pi over 4 is 2.35 and it falls in quadrant 2. Quadrant 2. However, if you know the unit circle, do we have a 3 pi over 4?
Yeah.
Where is that at? Is it a 45 or is it a 30/60? 3 pi over what? 4. So it's a 45. So what do I know about the coordinates? What are the coordinates? Why? Everybody okay with that? You are okay with that? You should be. What's your ratio for cosecant? What's cosecant match with? No, it doesn't. No, sine. What is sine? Y over R, so cosecant would be? What is our R on our unit circle? 1. What's our Y coordinate that we're working with? Square root of 2 over 2. We can't divide fractions. We do what? So multiply by 2 over the square root of 2. And I get? Multiply straight across. Can't have that. And I get? Which is? What's that? All right, let's go to B. Let's go to B. What's different about B? It's clockwise, right? Instead of counterclockwise. So what do I do to it? You can add 360 or subtract it from 360. That is the same step. Okay, same thing, which gives you, yeah. Is 150 on the unit circle?
Maybe.
It is a major point.
Yeah, it is.
Yeah, it is.
It is a major point because 180 minus 30
Would be 150.
is 150. So think about that coordinate right there. What was that coordinate at 150?
Oh, it's the 2 over 2.
The 1
Square
over
root of
2.
2.
Oh, yeah, it's square root of
Yeah.
Why is it negative?
because it's in the second.
Same second quadrant. So we're doing tan. What's your ratio for tan? Y over X. What's your Y?
1/2.
What's your X?
Negative square root of 2 over 2.
We don't divide, we,
Would multiply.
what happens? Yes, you do.
Well,
Cancel the 2s. Can I have a square root of 3 on the bottom?
no.
No. On the top, 1 times the square root of 3.
Square root of 3 over 3.
And what did I have on the bottom as well? A negative. That's it. All right, 7 pi over 4, sine 7 pi over 4. You can. But it's over 4, right?
Yeah.
Yeah, so it would be as the 45.
45.
Where at?
Quadrant number 3. 4, 3.
3 or 4?
4. 4, yes. 3.
If you're not sure. Like some of us are. I get 5.49, which is quadrant 4. So if you go back up here, quadrant 4. So quadrant 4 has what signs? Positive, negative. Positive, negative. So your value for sine, what's your ratio?
X.
Y over R.
Y over R. If we remember using the unit circle, you don't need the R. So what's your Y?
Negative square root of 2 over 2.
That's it. Because it's unit circle and R is
1.
1. So if it's 1, divided by 1 does nothing. All right. What about the next one?
Cos.
360 minus 120.
That's quadrant 3.
Is that a good coordinate?
Yes.
What's at that one?
Square root
You have your book.
3
Open it
over
up and look
2.
at your unit circle.
negative 1/2.
What's your coordinate at 240? Negative 1/2.
Oh, I had it back.
Negative square root of 3 over 2. So if you're doing your homework, reference that unit circle in the front, okay? So then what's our ratio for cosine?
X over R.
Do we need R?
Uh,
No, we just need X, which is,
negative 1/2.
that's it.
Because it's 1. Come on now.
Dear God, how many times I gotta explain it? I literally just said it. He's on down. He's on down. All right,
Give it the program.
11 pi over 6.
4.
What is it over?
6.
Hey, check this out. 11 pi over 6 is where? Quadrant 4. It's almost the very last one, right? So what are my coordinates for that?
Negative.
Uh-uh.
Square root of 2.
Square root of 3 over 2 and 1/2. And if it's in quadrant 4, it should be negative 1/2. Tan is, you're trying hard. Okay, this one we have to use both. What is your Y? Over your X is? We don't divide, we negative 1/2 times 2 over the square root of 3. What happens?
The 2's cancel.
So we get,
Square root.
what kind of square root of 3?
Negative square root of 3 over 3.
That's it. Great job.
We're just.
Beasting it out, aren't you?
Are we your favorite class?
Oh,
Remember, I'm recording it.
Oh,
No, you're good. This one I did because they asked me to. All right.
so basically she can't.
Let theta be an angle in quadrant 2 such that sine theta equals 1 over 3. Find cosine theta and tan theta by using trig identities. All right. So trig identities are the ones that we talked about yesterday. All right. Which one relates sine and cosine? Think about yesterday.
That B sign.
No clue.
Y'all remember this one?
Not at all.
You should.
For sure. Maybe.
And then we had tan is sine over cosine. Those are the two that we're gonna use for this one and for the next one, okay? So we have sine squared theta plus cosine squared theta equals 1. What was sine? So we're gonna square that. How do I solve for cosine? How do I get this 1/3 on the other side of the 1/3 squared? Subtract it. A normal problem. Don't act like this is something new. Okay, to solve, we subtract the 1/3 squared. You can go ahead and square that if you want to, or whatever. If you'd like to see it in fraction form, it's 8/9. So we have cosine squared theta. I would put it in fraction form equals 8/9. And then how do I solve for just cosine? When you square root a fraction, you square root the top and the bottom. Remember to simplify, we're gonna break it down. 8 is 2 times 2 times 2. I have a pair of 2's that will come out. And I left a 2. So one more time, I break it down, prime factorize. Anything that you have pairs of, you're gonna circle. And that comes to the outside. I had a pair of 2's, and then I did not circle a 2, so it stays on the inside. What's your square root of 9? 3. So cosine theta equals 2 square root of 2 over 3. There's your first one. To find tan, remember that's sine over cosine. We know both of those. What is sine? 1/3. What was cosine? We don't divide. What happened?
The 3's cancel out.
What's wrong?
And square root on.
What do we multiply by?
No.
Just the square root of 2. Do not multiply by that other 2. Just what you need to get rid of. So on the top, 1 times the square root of 2 is? On the bottom, what would that have turned into if it was just square root 2 times square root 2?
2.
Times 2 is? That's it. Now, one more thing. What's this say?
Quadrant 2.
What is cosine in quadrant 2? You might have to go back and look at that little chart. Also, remember in quadrant 2, what is your X value? Negative. What about this one? Tan is going to be Y over X. So what would it be? Negative as well. One of them is going to be negative, one's going to be positive, negative over positive. So that's it. Okay, we're going to do it again. I know you are tired of listening to me, but that means you won't have homework. We'll have a work day tomorrow. So remember that. That way those people, anybody in here, some of y'all are taking the test tomorrow. If you leave, you'll just have homework and I can email that to you if you happen to leave. Okay. So we're not going to learn anything new. You're not going to miss anything in here if you decide to leave early from school. All right. Let theta be an angle in quadrant 3 such that sine is -4/5. Find cosine and tangent by using the trig identity. So the same thing that we just did. We're going to do -4/5 squared plus cosine squared equals 1. We need to move that -4/5 squared. And I'm going to do it as a fraction. So 9/25. This one's actually easier than the other one. 9/25. How do I get just cosine? What's the square root of 9?
3.
Square root of 25. We're in quadrant 3. Remember in quadrant 3, you have negative, negative. So cosine is your X coordinate. What would it be? negative. For your tangent, you have y over x. What's a negative over a negative? So our tan should be positive. So tangent of theta, remember, is sine over cosine. I'm sorry, what? Mm-hmm. What was your sine?
-4.
What was your cosine?
-3.
And you're gonna see that it's gonna turn itself positive. We don't divide, flip and multiply. Your fives will cancel out and you're left with,
-4.
which is just 4/3. And again, it should be positive in quadrant 3. All right, so you ready for the easy stuff?
Sure.
Okay, this is really quick. And I know that, yeah, we're gonna get out of here this quick. This is calculator. So what is this little circle right here mean?
Degree.
So do your mode in degrees. And remember that cotan is the reciprocal of tan.
1/.
So 1/tan 410. Leave it like this. Now, to save some time, let's do all the degrees first. So tan 119, I don't have to do anything weird with that, just put it in. I get negative 1.8040. All the rest are radians. So make sure that you know that all of these are in radian mode. So I'm gonna go back to my mode and highlight radian. Literally type in sine 7.6569, which would round to 6570. If you don't round it correctly, that's okay. Don't stress out. What is cosecant?
1/.
1 over
No.
sine 5.
Shut up, Dylan. Just shut up.
Secant is,
The reciprocal of.
so 1 over cosine pi over 9. And then cosine pi over 5, which is 0.8090. That's it. All right, work day tomorrow.